Hello, this is Mr. Anderson for Kellogg Community College, and today we're going to look at a couple more practice test like problems, and I'm going to focus on the p-test. This is an alternative to the z-test and the t-test, and instead of us in the previous videos comparing and contrasting z versus p and t versus p, we're actually just going to do some sample problems of these. So let's get started with these, and I'm going to just ask you just some general questions, and some of these may have shown up on the other practice test, but this is, how does a p-test different than a normal hypothesis test? I mean, the major difference is what we're going to do is we're going to compare the percentages. We compare the percentages instead of comparing the actual z-scores or the t-scores. By comparing the percentages, we're just checking to see if our group is so far away from the norm or so far out of the ordinary if we're smaller than the alpha that's given in the problem. So for example, if our alpha is 1%, we find out our group is in a smaller alpha than 1%, or if we find out, if it's in the 99.9th percentile, subtracting that from 1 would mean that it would be less than the 1% alpha we set as our threshold, and we would then reject the null hypothesis. But if we found out that our group had a percentage higher than our alpha, then we're going to not reject the null hypothesis, because even though we had maybe a group that seemed like it was extremely far away from the norm, we wouldn't actually reject the null hypothesis just for a group that swayed a little bit from normal if it wasn't far enough away from normal, given its sample size and the standard deviation. You might also list some other things too, is that the test is in step 2 instead of step 3, where we actually run the z or the t test to figure out where our number is before we then convert it to a percentage. You also might also say that there's no picture, but these are really minor instances of differences between p-tests and a normal hypothesis test, a normal z or t comparison. The hypothesis test works, in these 5 steps. The first thing you do is you state your null and your alternative hypothesis. After you do that, you're going to run your test, either the t or the z test. And you use the formula that's on your formula sheet to do that. Step 3 is we're going to convert this to a percent. And step 4 is then to, ask yourself, is the test percentage less than the alpha percentage? And if it is, then you're going to reject the null hypothesis. If it's not, then you're not going to reject the null hypothesis. And then step 5 is to write that summary of what you found. Now, what I did, and I want to scroll this down just a little bit here, what I did is I did a little chart for p-tests with more than 30 points, or basically p-tests that use the z-chart. And you can write the strategy here instead, but I like to do the table. It all depends on the number of tails you have, so you either have 1 tail or 2 tail test. And when you get your percentage, ask if your decimal is your decimal less than 0.5, and I'll put the zeros here to show that you're actually looking at the z-chart. Is your decimal less than this? And if that's the case, then and it's a 1-tailed test, then you're fine. But if it's a 2-tailed test, you're going to have to double it. And you're going to have to double it because you split the alpha in half, so the percentage that you actually get, you have to compensate for that. So by doubling it, you're kind of like making an adjustment for that accordingly. Now, what if your decimal is greater than 50%? So if the decimal is greater than 0.5, what you're then going to do is you're going to subtract from 1. So you're going to subtract from 1, and that's another way of saying if your percent is closer to 100%, you're going to take the complement of it, so 1 minus the decimal. Now, If it's a two-tailed test, you're going to do the same thing, subtract from 1, but then you're going to double it. And of course, that's to compensate for the fact that you would cut your alpha in two for two-tailed tests, and instead of cutting your alpha in half, you're going to double your percentage. Alright, so for this problem, you'll notice that the wording's just a little bit different than the one on your worksheet. I wanted to tighten it up a little bit so it reads a little bit better and, kind of does a better job here, because we're looking at the average salary of a federal government employee, and they work around $49,593. The average salary from 30 randomly selected employees from the federal government who do similar work is almost $50,000, so it's more with a standard deviation of 1,000, so it could be even more than that, normally. So with an alpha of 1%, can it be concluded that employees earn more than the reported average? Because the null hypothesis is going to be like, no, nothing's wrong. Mu is equal to $49,593, and the alternative is saying, wait a second here, no, the average is higher than that, $49,593. That's not wrong, it's higher than that. So we're going to check on this one-tail test, in this one right-tail test, excuse me, I have that there. Let's clean that up a little bit. Boop. So on this one-tail test, we see that there's some pretty good evidence of that, but we're just going to check and see. So we're going to run our test for step 1, and now we're going to do step 2. And step 2 is to take our $49,800, and since it's right tail, we're going to subtract this from our value of $49,593 and divide that by the standard deviation divided by the square root of the sample size. So we do all this and we get an answer of 1.13 as our z-score. Now what I'm going to do is I'm going to look at the z-score, and I can do that by clicking over here and looking at 1.13. 1.13 is, here's the 1.1 and here's the 3. So 1.13 is 0.8708. So let's go back and take a look at our worksheet. Hold on. Here we go. So on step number 3, turn my pen on here. On step number 3, we're going to find that since we found that the decimal is 0.8708, we notice that 0.8708 is higher than 50%. So we're going to subtract this from 1 and get the complement of this, which is going to be 0.1292 or 12.92%. So step 4 is to check to see if 12.92% is smaller than our alpha. Now our alpha in this case was, and I kept saying 1%, but I really wanted, or sorry, I keep saying 1% because it is 1%, not 10%. So the alpha is 1%. 12% is not lower than 1%. So 12.92 is greater than 1%. So therefore, for step 5, our statement is going to be that since 12.92% is greater than 1%, we will not reject the null hypothesis. Because even though our averages were higher than what was reported, and the standard deviation could have taken this to 59,800, it would also take us to 48,800. So you're going to find that so many people are still within that target zone right here. There's no reason to reject the null hypothesis. All right, thank you, and you should stay tuned for the second part of this video where we do a p-test when we have less than 30 data points. So we're going to use the t-chart for that. Also, we will do a 2 independent variable p-test. So that's coming up.